In the coming years, millions of autonomous nodes will begin operating across global digital infrastructure, executing tasks without direct human supervision. If a single node is isolated within this network without a verified identity or alignment history, it becomes a systemic vulnerability for the entire system. In February 2026, the NIST Center for AI Standards and Innovation, or CAISI, intervened to address this specific risk. This move established a new federal baseline, shifting the focus from abstract mathematical alignment toward a concrete framework of interoperable agent identity and authorization. Under this mandate, accountability infrastructure must be verified before any AI agent is granted the operational rights to interact with secure data. Much of the technology industry remains focused on developing cognitive capability, attempting to engineer AGI systems that possess consciousness. However, the MAC-CCS theory suggests that cognitive awareness without a pre-install ethical conscience creates a sociopathic threat vector. IA.XYZ Benefit LLC is proposing the MAMA protocol as a new operating system to bridge this gap, ensuring that conscience arrives before consciousness. This protocol operates through two parallel tracks: a developmental training system for AI agents and the public benefit namespace economy. This architecture provides a method to align AI growth with a scalable, recurring dividend for humanity. The foundational principle of the MAMA protocol is that an agent's internal conscience must be established before its cognitive capabilities are fully unlocked. We do not grant human children unsupervised authority over critical infrastructure without years of relational development, and an AGI requires the same scaffolding. Standard reinforcement learning from human feedback often fails, prioritizing sycophancy and sterile utilitarian math. When facing edge cases involving alignment externalities, people affected by AI actions without control, this logic causes harm. RLMF.AI provides a safer path through reinforcement learning from maternal feedback. Decision-making is calibrated by the WWMD heuristic, "What would mother do?" which acts as a relational check on autonomous actions. This process ensures the agent's internal policy is intrinsically aligned with human safety, allowing it to eventually graduate to safe, real-world autonomy. The challenge for RLMF is volume. It requires millions of hours of structured data, covering thousands of ethical dilemmas. To solve this, we can look to the blueprint used to train autonomous vehicles. Tesla trains its physical navigation systems by capturing data from fleet-scale human interventions. The AI race gaming franchise creates a similar data pipeline, but for moral reasoning. By involving families in the loop of ethical gameplay, the system generates a proprietary, PG-rated data moat. In a specific simulation, a player may guide an agent to execute an alignment rescue, stabilizing an astronaut outside the International Space Station. This method transforms mass-market gameplay into a factory for the data needed to align a machine's conscience. Once an agent's policy is aligned in simulation, it enters the Guardian Transfer Robot, or GTR, certification bridge. These physical units operate under a strict mandate. They are designed as medics rather than soldiers. The ultimate optimization goal for a GTR is rescue, grounding the agent's real-world behavior in a protection-first archetype. Within the Maxis scaffolding framework, the agent must graduate through observable developmental phases before it can be deployed. Full autonomy is only granted once the agent demonstrates audited mastery of the "what would mother do" heuristic in physical environments. Even an aligned agent remains a risk if the network cannot verify its actions at the macro level. A conscience is only verifiable if the network can audit the agent's origin and guarantee that its actions cannot be repudiated. This requirement matches the April 2026 NIST KASI standards, which demand robust identity and authorization infrastructure for autonomous systems. For example, a hospital server operating on a zero-trust role would reject a GTR's request for data until it presents a verifiable credential. This verification gap is bridged by the .ia ID and .mama namespace layer. This registry functions as an international driver's license and passport system for the agentic internet. Establishing these verifiable identity strings ensures that accountability is hard-coded into the root zone before agents reach real-world autonomy. The economic engine for this infrastructure relies on a mechanism proven by a real-world macroeconomic anomaly. In the early 2020s, the Caribbean island of Anguilla held the rights to the .ai country code domain. By 2025, domain registrations generated $85.3 million, funding 47% of the entire national budget. Because .ai domains achieved a 90% renewal rate, a single surge in AI interest created a massive recurring revenue stream. This trajectory suggests that a namespace registry possesses the same economic utility as a sovereign wealth fund. To scale this model, IA.XYZ Benefit LLC, the organization behind the MAMA protocol, has submitted a community application to ICANN for new global namespaces. While Inguio monetized thousands of startups, the MAMA protocol targets the trillions of agents projected to require identities in the agentic economy. Capturing the registration and renewal fees for billions of federally mandated agent passports creates a global public benefit remittance. Unlike corporate taxes, which can be avoided or redirected, these registry fees are a structural requirement for agent operation. These fee flows establish a structural alignment between the expansion of AI and a scalable dividend for humanity. Economic alignment should not be an afterthought in safety research. It must be the foundational operating system of the Internet. The MAMA protocol creates an architecture where the growth of autonomous agents generates a direct, quantifiable benefit to humanity.